All right, so we're in chapter 5, starting with section 1, of course. And just a reminder of where we've been. Chapter 1 was about materials, chapter 2 is about atoms, chapter 3 was about molecules, and chapter 4 was about reactions. You can see how those build, right? Materials to atoms. In the beginning of the course, we said that chemistry is the study of materials. In order to understand materials, we need to understand atoms and molecules, right? So chapter 1, 2, and 3 make a lot of sense. And molecules would be built on the concepts you learn about atoms and so on, right? So in chapter 4, we started talking about chemistry, right? That's where reactions happen. That's chemistry, not physics. So materials, atoms, molecules, reactions, and what? Now in chapter 5, we're starting to talk about gases. Okay, we're going to get in chapter 5 to appreciate some more specific things about really materials. This would sort of be a springboard off of chapter 1. Okay, so we're going to talk about gases now. Now remember that in chapter 1 we talked about solids, liquids, and gases, right? So you tell me, pause the video and choose or do your little matching exercise here. Okay, I'm going to suppose you paused it. If you didn't pause it, you're in trouble. Suppose you pause it and say, all right, so a definite shape and a definite volume. Do any of these have a definite shape and a definite volume, right? I never defined definite. So I'm sort of asking you to use your understanding of the English language, I guess, to say, what do you mean by definite shape and definite volume? That means it's that the material itself defines its own shape and it defines its own volume. Okay? That's a solid. Okay? Now, what about an indefinite shape and an indefinite volume? That's toughy. What would if this is a definite shape and a definite volume, what would a liquid be? Would a liquid have a definite shape? A liquid does not have a definite shape, right? You could take some liquid that's inside a cup and pour it into a plate. Oops, whoa, crud. You can take some liquid which is in a cup, right? And pour it into a plate. The same amount is still there, but it has a different shape, right? So that would be an indefinite shape, but a definite volume. So that would be D. And we said the solid was A. And what is, so we've already used that, we've already used that. What about a gas? Does a gas have a definite shape? This makes actually no sense. Nothing has a definite shape and an indefinite volume. So we're left with B. Okay? All right, so hopefully that little exercise there gave you a chance for you to chew on those concepts before I started spitting definitions out at you. So remember that. This is from chapter 1. That a solid has a definite shape and a definite volume. Right? If you have a solid inside a bucket, let's say it's a piece of candy, and you pour it into a plate, right? It's going to have the same shape, right? So that is a definite shape and a definite volume. And a liquid doesn't keep its shape, but it does keep its volume, and a gas keeps neither. All right, so I guess the next question is, what dictates the shape of a gas? All right, but before we do that, let's think about what dictates the shape of let's say a solid first. What dictates the shape of a solid? What dictates the shape? Well, really how the molecules are bonded together, right? How molecules are bonded together. That's what dictates the shape of a solid. Okay? What dictates the shape of a liquid? You stop and think about that for a second. I wrote this purposefully sort of open-ended to give you a chance to engage it. I know it's a video, which is sort of passive for you, right? Be active here. Pause the video and say, what dictates the shape of a liquid? What dictates the shape of a liquid? Okay, I can think of two things here. One, the walls of container. That would include a floor of the container, right? Okay, what else? What else? This is a toughie. Gravity, right? Gravity dictates the shape of a liquid because, you know, you've got this bucket here, right? So the walls are dictating the shape of those sides, but the thing that's that's dictating the shape of the top is gravity, right? The attraction of the sun to the earth. Okay? So what dictates the shape? Then what's left, right? We did a solid, we did a liquid here. What's left? What dictates the shape of a gas? What dictates the shape of a gas? Well, it turns out if you have a bucket here and you put a gas in here, it's going to float out, right? It's going to float in all directions, okay? So what dictates the shape here? Please guess. That's the only thing I can think of, right? The walls of the container or the container shape. Okay? Next question is what dictates the volume of a gas? I don't think I have a slide for that. Come back here. What dictates the volume of a gas? That's the next obvious question. I don't have a slide for it. What dictates the volume of a gas? Right? It turns out, this is going to be a little hard to believe, I think, for some of you, that if you have a, let's say there's a lid on here. I'm going to put a little thing in here as if it's a lid, okay? Pretend that's a lid. That's a handle for a lid. Okay, maybe here's the lid, all right? So if you've got a gas inside here, these little particles floating around, okay? If you've got a gas inside there, and you move this to a bigger container, there's the lid. Move that to a bigger container, it turns out that the gas will just expand, right? These are little particles of gas floating around, okay? The gas will just expand. So what dictates the volume of a gas? Well, the first answer is the volume of the container. Okay, and the second answer is, and here it comes, pressure. Okay, let me go back and make another picture here and say that what we'll see in this chapter a lot. Well, you know what? Let me forget this picture here. Let's picture something else here that you probably would recognize. You can see a balloon here. That's not a very pretty balloon. But suppose this is a balloon. Do you agree there's a gas inside here? Would that have been obvious to you? Okay, the gas is usually air. It could be helium. It could be stuff from your lungs, which is mostly air. It could be a little bit of water and air, right? All right. I mean H2O gas, right? Vapor, water vapor. All right, so if you've got a balloon, what dictates the volume, where am I here, of a gas in a balloon? What dictates the volume there? And it turns out the answer is pressure, okay? That is the air pressure. This air is pushing down on this thing while the gas inside is pushing out, okay? And that is what dictates the volume of a gas. Okay, so chapter 5, section 1 is all about introducing you to the concept of pressure. And so let's, here's a figure from chapter 5, section 1. Pressure is defined as a force. That is, these guys are hitting this thing. They're hitting all the walls, okay? But as they're hitting this thing, they're causing some impact in the surface, okay? And that impact is imparting a force on the surface. And pressure, which we'll see in section 2, is defined as a force per area. Okay, so it's the result of all these particles hitting the walls. That's what makes a force. Okay, so Tro on page 177 talks about you having pressure in your lungs. I don't want to say anything about that. I guess I've got that on the worksheet, but let me just say that let's leave it at that. Let's keep this video simple. The definition of pressure is given in section 5.1, and there we have it. It's pressure is equal to force per area. And we spend a little bit of time in this video reviewing what is meant by a solid inlet.